a review of the Edgenuity lesson, Right Triangle Trig. So on this lesson, they kind of throw a lot at you at once. So this video might be a hair longer than our other ones. So for right triangle trig, the three trig ratios that they talk about this lesson are sine, cosine, and tangent. And the way we set up the ratios is, let's say, for example, I'm going to choose, depending which angle you choose as your reference angle, it changes the way you write the side. So I'm going to use angle B here as my reference angle. So now I'm going to fill in the names of all the sides of our triangle. Always opposite the right angle, the longest side, we always call that the hypotenuse. The side that's across from angle B, because like I said, that's the one that I'm referencing right now, across from angle B, we call that the opposite leg. And then the last one here that's touching B, that's not the hypotenuse, this one we call the adjacent. And we use those three names there to help us set up our trig ratios. So in the video, they talk about SOHCAHTOA. It's just a little acronym to help us remember how it works. So sine of our angle B is, so sine always goes with the angle measure. So the sine of the angle is the opposite leg over the hypotenuse. That's how you set up that ratio. Cosine for angle B is the adjacent side over the hypotenuse. That's why it's AH there. And then lastly, the tangent of angle B is the opposite leg over the adjacent leg. So SOHCAHTOA is what's, remember those ratios there. So for example 1, it says, what are the sine, cosine, and tangent ratios for angle A? So this is our reference angles. But before I start anything, I'm going to write what all of those sides are called. Opposite the right angle is always the hypotenuse. Okay, so from angle A, the leg that's across from it is your opposite, and the leg that's touching it is your adjacent. So for sine of angle A, sine is opposite 4 over hypotenuse 5. So sine is opposite over hypotenuse. Cosine for angle A, cosine is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 5. And lastly, tangent for angle A, tangent is opposite over adjacent. So opposite leg over adjacent leg, 4/3. So for example 2 here, we have to find the value of x. So let's see, angle B is our reference angle here. They give us the hypotenuse. And what side are we looking for? What would we call this side? The adjacent. So we're looking for adjacent, and they gave us hypotenuse. So we need to do the trig function that has the A and the H. So the one that has the A and the H, that's this one. So I know I need to use cosine to solve for x here. So I'm going to say the cosine of my angle, which is 40 degrees, equals the adjacent leg over the hypotenuse. Now, when you go to do trig functions in your calculator, you need to make sure that your calculator is in degree mode. So if you're using a TI-83 like I am, you hit mode here, and this part here should be highlighted. You should not be in radians. Oops. It should not look like that. So if yours look like that, you need to go down to the third line, scroll over, and select degree there. Okay, so cosine of 40 degrees, that's just a value. There's a sine, cosine, and tangent button on your calculator. So if I do cosine of 40 degrees, it's just going to give me a decimal there. So I'm not going to round it though, because then it's not going to give me an exact answer. So what I'm going to do is I'm just going to get x by itself and then worry about the cosine 40. So x divided by 10, to undo dividing by 10, we just multiply both sides by 10. So in my calculator, I'm just going to plug in 10 times cosine of 40 degrees. And we get about 7.7 would be the length of the leg there. Okay, so on this one, instead of solving for a side length, we're going to solve for an angle measure. So we're solving for the measure of angle A. So that's our reference angle. So let's see what they give us, because then that's going to tell us which of these three trig functions we have to choose from. Okay, so this is the hypotenuse. It's opposite the right angle. And if we have 14 and that's all the way across from angle A, that is our opposite leg. So we have opposite and hypotenuse. So which trig function has the O and the H? This one. So that means we know that we need to use sine. So sine of angle A equals opposite leg over hypotenuse. So now we need to get A by itself. And there are actually inverse trig functions that undo our sine, cosine, and tangent. Just like if we had x squared equals 49, if I wanted to undo the squared, I'd have to square root both sides. So we need to undo the sine. And if you notice on your calculator, above your sine, cosine, and tangent buttons, there's a sine with like a little -1 exponent, a cosine power of -1, and a tangent to the power of -1. Those buttons there, those are your inverse trig functions, and they undo your trig functions. So if I wanted to undo sine, I would take the sine inverse of both sides. Sine inverse cancels out sine, and we get A equals, I'll write it out first, sine inverse of 14/20. So lucky for us, it's a button on our calculator. So I would just go second sine, so it's sine inverse pops up, and I would just do 14 divided by 20, close the parenthesis, and we get about 40, the measure of angle A is about 44.4 degrees. Next, they talk about 30, 60, 90, and 45, 45, 90 triangles. These are just, they're called special right triangles because they have special properties for them. So I'm actually going to do the 45, 45, 90 first. So this one, it's an isosceles triangle because these two base angles are the same, so that means the legs are the same length. So the way it works, the special property for this one, is if this value was x, this value would be the same thing, x, and the hypotenuse is always going to be x times the square root of 2. So, for example, if I knew that this was 4, then I would go 4, 4, 4 root 2. If it was 10, it would be 10, 10, 10 root 2. That's just the way it works every single time. Similarly, if I knew that this was, let's say, 3 root 2, and I wanted to figure out what the two x's were here, well, if it's x times the square root of 2, and this is 3 times the square root of 2, that means the x is just 3. So I would just pull that root 2 off, and these two side lengths would be 3 and 3. So looking at this example down here, we'll just go straight down into it. This is a 45, 45, 90 triangle. There's 180 degrees in the triangle, so if I subtract 90 and 45, we figure out that this is also 45 degrees. So we know these legs are the same. And this 5 root 2 is sitting in the x root 2 spot on the hypotenuse. So if I wanted to figure out what x by itself was, we just pull that root 2 off. X is 5. So both these legs are 5 and 5. For a 30, 60, 90 triangle, the 60 degrees is always opposite the longer leg. Not the longest, because that's the hypotenuse, but the longer of the two legs. 60 degrees is also opposite that. 30 degrees is opposite the shortest leg in the triangle. So the way that this one works, opposite 30 is x, the hypotenuse is 2 times x, and opposite 60 is x times the square root of 3. So like here, if I knew that this was 7, this would be 2 times 7, which is 14, and this would be 7 times the square root of 3 is how that would work. And then the same properties similarly to over here work for solving it. So like, let's look down here. Oops, no writing a box. Okay, so this is a 30, 60, 90. The 12 is sitting in the 2x spot. So if I know that I had to double x to get 12, x on its own would just be 6. So opposite the 30 degrees is just the x on its own, 6. Opposite 60 degrees, you just tack on a root 3. So this would be 6 root 3.